All right, so I've had some requests for some more examples on the radical chapter, simplifying radicals and graphing. So we're going to do some more examples of those. So this is simplifying -2 times the square root of 243 x to the 7th y to the 11th. So the -2 we're just going to ignore for now, and we're going to find the factors of 243 that have a whole number square roots. You can Google these, and I'm just going to tell you right now it's 81 and 3. And I know that because I made up this problem. All right. So underneath the radical sign, when I write the 81 times the 3, and now we need to break the x to the 7th up into two parts where one is a multiple of 2 and the other one is the remainder, because if it's a square root, the index is 2, so we need multiples of 2. So anytime it's an odd number, it's going to be 1 less than this exponent, so x to the 6th, because 6 is a multiple of 2. And then 7 minus 6 is 1, so you have x to the 1st still left. So those are our two x's. And then we're going to do the same thing with a y to the 11th. So you're going to subtract 1 from 11. So we have y to the 10th. And then 11 minus 10 is 1. So we have y to the 1st. And then we still have this -2 out here. And now what we do is we take the square roots of what we can. So we know that the square root of 81 is 9. So we have -2 times 9 out here. 3 does not have a square root, so it's going to stay. And if you want to underline it so you know it stays. And then the even exponents, because it's divisible by 2, you're going to take 6 and divide it by 2, which is 3. So then x to the 3rd power goes out here. 1 divided by 2 is not a whole number, so that is going to stay underneath the radical sign. And then 10 divided by 2 is 5. So then y to the 5th is outside the radical sign. And then 1 divided by 2 is not a whole number, so that's the other one that stays. So the 3, x to the 1st, and y to the 1st are left underneath the radical sign. So you have 3xy under there. And then our last step is to multiply this -2 times 9, which is -18. So we have -18 x cubed y to the 5th radical 3xy. And yes, I know there are 1s and the exponents up here for the x and y, but you don't necessarily need to write those. And so this is our final answer for this problem. So another square root one, we have the square root of 675 x to the 12th y cubed. So instead of listing out all of the factors of 675, I believe I did 125. Nope, I did 225 times 3, I believe. Yep. So we have 225 and 3. So those are factors of 675 where one has the largest square root. So we're going to break this up. So remember our index here is 2. So this becomes 225 times 3. All right, so 12 is a multiple of 2, which means we don't have to change the 12. It's just going to stay x to the 12th. But 3 is not a multiple of 2, so subtract 1 from 3, and we have y squared. And then 3 minus 2 is 1, so times y to the 1st. Now, the square root of 225 is 15, so that's going to go outside the radical. The 3 does not have a whole number square root, so it's going to stay. And then, because this is divisible by 2, you're going to do 12 divided by 2, which is 6. So x to the 6th is outside the radical, and there aren't going to be any x's left under the radical sign. And then 2 divided by 2 is 1, so we have y to the 1st power out here. And you can write the 1 if you want to. I'm not going to. And then 1 divided by 2 is not a whole number, so that is going to stay underneath the radical. So what's left under here is 3y. And that's the final answer for that problem. All right, so that's square roots. I also going to do a couple cube root examples. I don't have any fourth root ones. I can do some more if we need them later on. All right, so the factors of 375, where one has a cube root, is 125 and 3, because 125 has a cube root. So we're going to break that up so that we have 125 times 3. Now, we need, instead of a multiple of 2 as an exponent, we need to break these up into multiples of 3. So if you're unsure of what the multiples of 3 are, they're 3, 6, 9, 12, 15, 18, and so on. So the closest multiple of 3 to 7 is 6. So we're going to make this x to the 6th times, and then 7 minus 6 is 1, so x to the first power. And then 9 is a multiple of 3, so we can leave this as y to the 9th. All right, so the cube root of 125 is 5. There is no whole number cube root of 3, so that's going to stay underneath the radical sign. And then 6 divided by 3 is 2, so we have x squared. 1 divided by 3 is not a whole number, so that one stays. And then 9 divided by 3 is 3. So we have y cubed outside the radical. And because there aren't any extra y's, there aren't going to be any y's left under the radical sign. So we have 3 and x that are left under the radical. So we have the cube root of 3x. And there is our final answer for this problem. All right, so another cube root example. We have 4 times the cube root of 448, x to the 21st, y to the 14th. All right, so the factor of 448 that has a cube root is 64 and 7, because 64 has a cube root. So we have the 4 out here, and then the cube root of 64 times 7 times, now 21 is a multiple of 7, so we do not have to change the x at all. We're going to leave it as x to the 21st power. Now, for 14, the closest multiple of 3 to 14 is 12. So we're going to make this y to the 12th times, and then 14 minus 12 is 2, so 14, or y squared is next. And now it's just simplifying. So we have 4 times, and then the cube root of 64 is 4. There isn't a cube root of 7, so that's going to stay. And then 21 divided by 3 is 7, so we have x to the 7th. 12 divided by 3 is 4, so this is y to the 4th. And then 2 divided by 3 is not a whole number, so that's the one that's staying. So left under the radical sign is 7y squared. And then the last step is to multiply 4 times 4. So we have 16 x to the 7th, y to the 4th, times the cube root of 7y squared. That is our final answer for simplifying that problem. All right, so the next two are reviewing the graphs. I don't have the graphs on here. We're just going to make the tables, because once you have the tables, you know how to graph the points. So we have the function f of x equals -2 times the square root of x plus 7 minus 2. All right, so anytime you have a square root function that you are graphing, this is your immediate starting table, because these are your x's that have perfect square roots. These are the square roots. And then we're going to change the values of this table based on this -2, this +7, and this -2. All right, so our second table is here. So the one that changes the x value is the one that's under the radical sign. So we have +7. So because it's underneath the radical sign, it changes signs from here to the table. So if it's positive 7 here, it becomes negative 7 in the table. And then the negative 2 here and the negative 2 here, which they're not always going to be the same. I just happened to make them that way on accident. Just picked random numbers. Are going to change the y. So this negative 2 times the radical doesn't change at all. It just comes down as negative 2 times the y because it's multiplication here. So it's going to be multiplication there. And then because this minus 2 is outside of the radical sign, it's going to stay minus 2 here. It just comes straight down as well. And it's going to stay minus because it's a minus sign, not a negative sign. All right, now, the next step, you're going to take the x values in this table and follow this function. So we have 0 minus 7, which is negative 7, 1 minus 7, which is negative 6, 4 minus 7, which is negative 3, and 9 minus 7, which is 2. So those are our new x values from this table to this one. All right, now to get the new y values, you're going to take the y values over here in purple and plug them into this y and get your new value. So negative 2 times 0 is 0, and then 0 minus 2 is negative 2. Negative 2 times 1 is negative 2. And then negative 2 minus 2 is negative 4. The negative 2 times 2 is negative 4. Minus 2 is negative 6. And then negative 2 times 3 is negative 6. And then negative 6 minus 2 is negative 8. So now these are the new points that you're going to graph to get the graph of this function. Because this is the table for the square root of x. This is the table for this function because the negative 2 here, this positive 7 and the negative 2, move and flip and change your graph from this. All right. So then a cube root function to graph. So we have the cube roots of x minus 3 plus 4. So this is the basic function of the cube root of x. So this is always the table you're going to start with when you are graphing a cube root function. All right, so over here we're going to we have x and we have y. And then we're going to put our changes with it. So we have minus 3 underneath the radical sign. So since it's minus underneath the radical sign, it changes sign down here and becomes positive. Our a in this case is 1, so we don't have anything to multiply here. And then this plus 4 stays positive 4 and just comes down here. And so now we're going to take negative 8 plus 3. So negative 8 plus 3 is negative 5. Negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 8 plus 3 is 11. And now we're going to take our y values and add 4 to them. So negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. And there is now the graph of our cube function after we shift everything. All right, and that's all the extra examples I have. If you need more, just let me know. Have a good day.